Okay. So basically today we will be talking about functions and limits. Okay. We are already familiar with what exactly a function looks like. It is nothing different. It's just what we have been studying. Okay. For example, f of x equals x squared plus 2x plus 4. This is a function. Let's say I talk about a cubic function. So I would say g of x equals 1 plus x cubed. This is a cubic function. Let's say I talk about any exponential function. So that would be e to the power x squared, stuff like that. Okay. So we all know what exactly a function looks like. We have been talking about functions already. We know we have trigonometric functions, quadratic functions, linear functions, cubic functions, logarithmic functions, exponential functions, and whatnot. Okay. But today we will be talking about limits in specific. Now we don't talk about this topic in A levels, but it is very easy. It's not difficult. I'll tell you. How is it different from limits? This is a simple function, and I will rewrite this function with limits, and then you will see the difference. So let's say I am writing down f of x. F of x is defined in the same way. It is x squared plus 2x plus 4. But with this, since I'm talking about limits now, so I'll write down LIM. This is a short form for limit. I'll write down the variable, arrow, and then some number. Let's say a. Now I'll tell you. This is just a basic substitution. Okay. This says that you have a function f of x and it says limit x going to a. What exactly this means? How do we interpret this? For the interpretation, just know we will be substituting x equals a in the function, and whatever we are getting, that is going to be the answer. For example, if I talk about this example specifically, so if I plug in a instead of x, I would get a squared plus 2a plus 4. Okay. Let's talk about the second example. Again, we have a function. Here we are talking about functions with limits. Okay. So this time around, let's say I have g of x and I am taking limit lim x going to 0. So how am I going to write it down? 1 plus 0 cubed, and that is going to be 1. Okay. And if I talk about the last example, let's say the function is h of x and I am taking limit x is going to infinity. We'll be talking about this stuff today. So that would become e to the power infinity square is going to be infinity. So e to the power infinity is going to be infinity. Okay. Now what do we know exactly? Just give me 1 second, please. All right. Okay. Yes. So that is the idea. Now, this is not that straightforward. By now, we know how to exactly deal with limits. Okay. Limit at your level is just this, that you would be having a basic variable in the function like x, and you'll be plugging in some value for x. Now, these examples were good. These examples were fair enough, other than this one. But this answer was okay. This answer was good. This answer, we'll talk about it. Okay. So when we talk about limits, it could be that once you're plugging in the limit, you are getting a proper integer. It could be positive, it could be negative, it could be 0, it could be a decimal number, it could be a fraction. That is okay. But then we have some indeterminate forms. When we say indeterminate forms, they are basically some undefined forms. Okay. Some forms which are not acceptable, and we need to modify the function just so when we plug in the limit again, we get something better. So first, let me write down the indeterminate forms, and then we'll talk about examples and I tell you how to modify the function. So any confusions with the basic idea about what exactly limit is? Yes, Alina and Ahmed? Okay, Ahmed, are you there? Okay. All right, so I'll clear the screen and now we'll talk about some indeterminate forms. Some forms which are not acceptable, or you can think about it as if undefined, because so far we've been calling all this undefined, but that is not only for infinity, we have multiple cases. Okay, so let's see. So we have 9 in total, and then you will see that using these, we would be able to talk about some more. Anyways, let's say if you have a function, for example, I'll be giving you some simple examples at the moment, and then I'll talk about the complicated ones as well. Let's say we have f of x equals x squared minus 2x, and the question is f of x going to infinity. So when you plug in the limits, it would give you infinity minus infinity, and this answer is not acceptable because this is the very first indeterminate form. Okay, now whenever we are coming across any indeterminate forms, we will be modifying the function using some ideas, and then we'll plug in the limit. So I'll come to the modification later on. Okay, so infinity minus infinity was the first one. Then we have infinity to the power 0. So we have this concept that any number power 0 is 1. But what if you have infinity power 0? So that is indeterminate, that is undefined. We are not sure about it. Okay, then 1 power infinity. Again, if you have 1 and you have 1 power any number, that should be 1. But 1 power infinity is indeterminate. We are not comfortable with this. We want something proper. So we would not be accepting this answer. Then if you are coming across 0 by 0, that is also indeterminate. 0 power infinity. Then if you have 0 multiplied by infinity, then if you have infinity over infinity, then if you have 0 power 0, and then the last one is infinity multiplied by infinity. Okay, now we have discussed a few indeterminate forms, and these are basically all the forms which we will be talking about mainly. But yes, let's talk about an example just so things get more clear. All right. So yes, the very first example says, let's say we have a function and the limit is x going to 3. Now there's no problem with the limit. It's going to 3, and the function is x squared minus 9 divided by x minus 3. Now let's plug in 3 instead of x, and let's see if we are getting something that is acceptable or if we are getting indeterminate form. So it would become 3 squared minus 9 divided by 3 minus 3. It would be 9 minus 9 divided by 3 minus 3. That is 0 by 0. And this is an indeterminate form. So we cannot accept this answer. We need to modify this function first, and then we'll talk about the solution. Okay. First, let's just practice plugging in some values, and then we'll talk about how to modify the function. All right, so let me take out another example quickly. Okay. Since we'll be referring to exponential functions here again and again, so it's good that we talk about it. So here we have x going to e, and the function is x to the power p minus e to the power p divided by x minus e. All right. Now this is your function. Again, we'll plug in e instead of x. So this would become e power p minus e power p, e minus e, and this would give you 0 over 0. And certainly this is indeterminate form. So by now we know if we are plugging in the limit and if we are coming across any of these values, it could be infinity minus infinity, 0 by 0. This would be the most popular one. You can come across this one as well, then this one as well. So all of them are not acceptable. We need to modify the function and then plug in the limit. Okay. So I assume that this part is clear. Let's talk about how to modify the function. Okay. So let's see how to modify the function. For modification of the function, we have multiple methods, but there's one method which we can use every time, and that is called the Lopeters rule. Okay. So it is called all right, we call it L'Hopital's rule, and it says if limit x going to a for a function f of x is 0, and then if you have another function, let's say g of x, and the limit is x going to a, it is the same, and this is also giving you 0, then limit f of x over g of x, this can basically be calculated as limit x going to a f dash of x over g dash of x. Okay, now I'll explain this again. Okay, now it is called the L'Hopital's rule. It is not hospital, it is Lopital. Okay, so this is, let me write it down properly. All right, now let me write down the understanding or the definition in a way that is much more understandable, just so we can use it directly. Okay, so let's say this was the question: limit x is going to a, and you had f of x by g of x, and this was giving you indeterminate form. So this limit f of x over g of x would be equal to limit x going to a, but we have a modified function now. Initially we had f of x over g of x. Now we will differentiate the numerator. So f of x would become f dash of x, and the denominator would become g dash of x. Okay, this is the only thing which you need to remember. So far we discussed multiple examples. In some of the examples we were getting a proper answer. Okay, but in some of the examples we were getting infinity over infinity, 0 by 0, infinity minus infinity. All of them were indeterminate forms. In order to get rid of such answers, we need to modify the function. How do we modify the function? By differentiating the numerator and the denominator, and this would make things very, very easy for us. Yes, is that okay? You can just tell me and then I'll talk about an example with this. So let's say we discussed this example just now where we had limit x going to 3 and the function was x squared minus 9 divided by x minus 3. Also, it could be that once we are differentiating the numerator and denominator, still that doesn't work. Okay, it could be like that as well. So you will differentiate that again. You will keep on differentiating that until and unless you get a proper answer, an answer that is not in the indeterminate form. Okay, this is what I want you to understand. So we can write down undefined, and I've told you which cases are undefined. Okay, let's see. Now we know once we'll plug in x directly, this is going to give us 9 minus 9 divided by 3 minus 3, and this is 0 by 0. This is undefined, this is indeterminate, so we cannot talk about it directly. We need to modify the function first. Okay, so limit x going to 3, x squared minus 9 divided by x minus 3 is equal to limit x going to 3, the derivative of the numerator, this is my numerator, x squared minus 9. So the derivative of x squared is 2x, and for 9 it would be 0, divided by the derivative of the denominator, it is x minus 3, so it would be 1. And now when I will plug in the limits, it would give me 6. So this is going to be the answer. This is going to be the answer. So always remember, when also, if you are not interested in differentiation would work in every question, okay? But still, if you are not comfortable with differentiation and stuff like that, you can talk about some other methods as well. For example, let's say, so this was the question. So x square minus 9 means x square minus 3 squared divided by x minus 3. All right, now I can modify the numerator by not doing something, but just by factorizing it, because we know it is a square minus b square. So its limit x going to 3. I'll just simplify this. It can be written as x plus 3 into x minus 3 and divided by x minus 3. Again, the limit is x going to 3. X minus 3 and x minus 3 can be cancelled. And now when I'll plug in the limit, this would give me 6. Okay, so this way, or by using the L'Hopital's rule, you can do it. L'Hopital's rule would work for every question. That is why I just wanted to talk about this. But this could be more understandable at times, and this might make more sense to you guys. So it is completely your choice. Okay, we will just talk about some questions, and there we'll see how to make such decisions. But yes, this is the idea about this chapter. Any doubts so far? Anything that you have not understood? Yes, Alina and Ahmed, please tell me. I'm waiting for your response. Yes, Alina, is that okay? Okay, and what about you, Ahmed? Please ask me if you have any questions. Yes, Ahmed, any questions? Okay, all right. So this was the L'Hopital's rule, and yeah, so far we have discussed what exactly a function is. We know multiple types of functions, so that wasn't something new. New part was function with limit. When we talk about the limit, we're just plugging in this value in the function, and if you're getting something undefined, you can either factorize it, cross out the numerator denominator, or you can use the L'Hopital's rule. When we say L'Hopital's rule, you can differentiate the numerator and denominator and modify a function, and keep on doing that until and unless you're getting some proper answer that is defined. But it could be that for some cases you are not able to differentiate it, and we do not have too many cases. I'll just talk about two main theorems, and then two would be coming from that, and then we'll be using those for those questions. Then once we are done with this, we are done, we'll just talk about the questions. Okay, now we have some standard limits. Okay, some standard limits. The first one is limit x going to infinity and the function could be something of this type: 1 plus p by x to the power x. Okay, now let's stick to this example first. Now we certainly know once we'll be plugging in infinity, what would happen? It would become 1 plus p over infinity whole power infinity. P by infinity would be approximately 0 because it is P divided by something very, 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 very big. So you can think about it as 1 to the power infinity. And we know that this is indeterminate form or undefined form. This is not something which we can accept. So we have a standard case, and the answer for this case is going to be e to the power p. And this only holds whenever p is a real number. So this means for every number in maths, it could be 0 0.1, 0 0.2, -1, -2, 35, 36, 1000, 1 billion, any number that is a real number. It should not be a complex number. So things would work. Okay. So this was the first example or first standard limit of first theorem. It is basically a theorem, but I've just written it down in such a way that it looks like a simple formula. So what exactly it is? If you have 1 plus p by x to the power x, okay, p could be any number, the answer is going to be e to the power p. Now, why do we have these standard limits? Because yes, we can differentiate it through a very, very long method. We do not have that much time, so we would be having some cases where we will be factorizing for modifying the function, where we'll be using the Lopital's rule, and it could be we are not able to use the Lopital's rule, we are not able to factorize it. So for those cases, we will be using these theorems. All right, this was the first one. And then if I talk about the second one, so it is limit x is going to 0, 1 plus px 1 by 0. Okay. Now, what exactly is happening in this form again? Again, we have that type of a thing. So you can think about it as 1 plus, yeah, initially this is x, and then it would become 0. Okay, now we'll plug in the limit. So it would be p into 0 and then 1 by 0. So this would become 0. So we have 1 to the power, now 1 by 0. Anything divided by 0 is infinity. So This is again the same indeterminate form which we were getting for the first part as well. And the answer is going to be e to the power p again. So for this, p could be again any real number. All right. Now, using these two, let's talk about two more cases which we will be using in particular for the questions. So it is, let's say you have limit x going to infinity 1 plus 1 by x whole power x. So yes, can anyone tell me what would be the answer for this case? We can use the theorems above. It's very obvious. Yes, Alina? So for the first question, like this is not the first question, but for this one, should we use A or B? For the question written in yellow, for the limit written in yellow, should we use A theorem or B theorem? What do you think, Alina and Ahmed? Same as first one. Very good. Okay. Yes. So we know that A and the first one are just the same. The only difference is instead of P, we have 1. So we can write it down as e to the power 1. And this would be the answer. And this is extremely important. We'll be using this in questions. And this is something which we don't cover in A levels. Okay. So Emma, please pay attention. This is very important for you. All right. And then if I talk about the second one, it is going to be limit x going to 0, 1 plus x to the power 1 by x. Okay, now this is the question, and again we can refer to B. It is just like the theorem B. The only difference is that instead of P, we have 1 again. Okay, so we can write it down as e to the power 1 because P is 1. P would be 1. This is 1. So P is 1. Here we also have P, so we will be writing down with 1. And yes, that is how we can talk about some of the limits which are not solvable by applying the L'Hopital's rule or by simple simplification. Okay, all right. So this much information is enough. Then I'll be explaining everything with the questions whenever needed. Right, so I'll stop sharing this. And now I am going to share the PDF. Okay. Yes.
Yeah, that A, is that the opposite of win?
Sorry, just give me 1 second. I'll share the other screen again. Yes, Eric said now.
Yeah, that E is just this variable over here, or is that
E is
E the opposite of
exponential.
line?
E is exponential.
The exponential, right?
Yes.
So you switched x by the infinity. 1 by infinity is equal to 0, and power infinity is equal to infinity. So why did we get an exponential?
This is what I was explaining already. This is what I was telling you. That 1 to the power infinity is indeterminate form. We cannot accept that directly. So A and B are two theorems which we use for such scenarios. Okay. Other than the L'Hopital's rule, I've told you you can just simplify the function. But for this case, if you have something of this type, 1 plus p by x to the power x, you won't be able to apply the L'Hopital's rule in this case. You won't be able to simplify it directly. So for such scenarios, the answer is going to be e to the power p. This is a theorem. Okay. Now, if you look at the first one, the only difference in A and first one is that instead of P, we had 1. Okay. So I was just trying to tell you that this would be the difference in the questions as well.
Yeah, I got it.
So, you know, just by changing the value of P. Okay, very good. And you'll see exactly how to just use this in other questions as well. Okay, so is that okay, Amit?
Yes.
Okay, all right. So I'll stop sharing this and I am going to share the screen again. Okay. Yes. So basically this is the question. All right. Now it says the very first example is this is my pen. Yes. Limit x is going to 0 and it says under the root 49 plus x minus 7 by x. First, even if you think it is indeterminate, let's just try plugging in 0 and see how things are, okay? So,
Infinity, right?
no, no. Under the root, just look at this, under the root 49 plus 0 minus 7 divided by 0. The numerator would become under root 49 would be 7, okay? So 7 minus 7 is 0 by 0, okay? So this is
Okay.
indeterminate form. So how do we fix it? By applying the L'Hopital's rule. What is the L'Hopital's rule? By taking the derivative of the numerator and the denominator and then plugging in the limits. So we know that this would be undefined. This is not acceptable. Let's just apply the L'Hopital's rule quickly. All right. Now I can rewrite the function as 49 plus x to the power 1 by 2 minus 7 divided by x. Okay. Let's differentiate this. So for the numerator, it would become 1 by 2 49 plus x. The new power would be 1 by 2 minus 1. So it would become minus 1 by 2 and the derivative of the bracket factor would be 1. Okay. Divided by 1. The derivative of the denominator, that is x, would be 1. So any confusions with the derivative part? Is that okay?
Yes, it's
Okay.
okay.
All
And
right. Yes,
I
yes.
thought that that square root was on 7 as well for some reason. If it were, uh,
Mhm.
the answer would have been infinity, right? Because anything divided by
Yes,
0 is
yes,
infinity.
exactly, exactly. Yes, you are right in that case. You're right in that case. Okay. So this would become, you can simplify this, it would become 1 by 2 under the root 49 plus x. The limit is not going to change. It is still the same limit x going to 0. So it would become 1 by 2 into 7 and that is 1 by 14. So the answer is going to be B. Yes. Alina, do you have any doubts with this? Please be honest with yourself and just tell me directly if you were not able to understand this. I'll wait for your response. Just take a minute, try absorbing this. And if you have any doubts, Emma, you as well, please feel free to ask me, okay? Okay, all right. So Alina has understood this. All right, very good. Okay. Now, since we are talking about functions and limits in this chapter, so the second question is about the domain of the function, but still we'll be using this stuff. Okay, it says the domain of the function h of x, that is under the root x squared minus 4. Now, one thing which we know about square roots is you cannot have negative number in that. Okay, you cannot have a negative number in the square root. So if this x is something less than 2, it would give you less than 4 and this would become a negative number. So for this, we can have all the numbers in maths except the numbers from 2, not from 2, like the numbers which are less than
Till 2.
Yeah, exactly, till 2. This basically, right? So minus 2 and 2 would work. We are going to get 0. That is completely acceptable. But if you have something less than that, so that would give you something less than 4 and that would give you a negative number. So we need to get rid of that. Now, how to choose such options? It cannot have all the real numbers. We have some exceptions. We need to exclude a few values. Real numbers minus 2, no, 2 would work. So this is not the answer. Let's talk about C. This is C basically. This is wrong. Okay, it says how to understand this set basically. It says X such that X belongs to R and it is greater than -2 and less than 2. So this is exactly the set which would be problematic for us. Okay, this is basically -2, 2, that is problematic. We need to get rid of this. So the answer would be D, because we have all the real numbers minus this problematic set. So that is why we are going for the choice D. Yes, any doubts with this one?
Many doubts.
Okay, sure, please ask me.
Okay. And the part D said there is no one.
Okay, no. I'll tell you. Basically, okay, wait a second. You know what? If I'm writing it down this way, wait a second, I'll just remove all this. Okay, I get your point. So other than 1, we need, 1.1,
Oh,
all those
there's
numbers.
that
Okay.
start, right?
Sorry, wait a second. Okay. So when we are writing it down
Okay.
as -2 and 2, you can interpret it as X between -2 and 2. Okay. We are not using these curly brackets. These curly brackets would have meant that we have -2 and 2 only. This basically means all the values between -2 and 2. Okay.
Oh, okay. Okay. The coordinates are written in these brackets. I mean, these are situational, right? We just have to know. Is that what this is?
Yeah, please say it again. I was not able to understand.
These are just situational, right? Like we just have to know when these brackets are meaning this or
Exactly.
something
Yes.
else.
Yes. You're right. I do understand
So what
that.
is part C saying?
Say it again. What is what?
So part C is basically saying greater than -2 and less than 2. This is the opposite, right?
Yeah, part C is basically referring to this problematic. It says all the real numbers intersection with this set. So that would basically give us all the values greater than -2 and less than 2. So this is again the same
Which
set.
is wrong, right?
Yeah. Okay. Yes. Very good. Okay. Alina, any doubts? Anything that you have not understood? Please ask me. Yes, sir. Okay. Teacher, please repeat it again. Okay. So basically, for the second example, it says we're looking for the domain of a function that has a square root. It says square root x squared minus 4. Now, you must be knowing that you cannot solve for any negative number in the under root. You get into the complex domain. This is not a real number. So whenever we are coming across under the root something negative, this is not done. Okay, we don't accept this, so we need to get rid of such values of x which would give us a negative number in the under root. Now we know that -2 squared would give you 4 and 2 squared would give you 4. So if you have, let's say, -3 squared or -4 squared or 3 squared, 4 squared, that would give you perfect answers. 2 squared would give you 0. Okay, but if you have, let's say, if you have 1, so 1 squared minus 4 would give you -3, and under root -3 is something which you cannot accept. Okay, this would not give you a real number, so we need to exclude these values of x. Okay, so which values are these exactly? Values greater than -2 but less than x, so but less than 2. So this is going to have -1, 0, 1, 1.1, 0.1, 0.001, and all these values. So for this domain, we have all the real values except this set, and this set is basically this set. Okay, we are getting rid of this, and other than this, we have all the values in all the real numbers in maths. Yes, is that okay now, Alina? Do you understand this? We have 0 also. Yes, I don't really understand your question. If you have 0, 0 would also be a problematic thing. Like if you have 0 minus 4, okay? 0 minus 4 would also be a problem. So 0 is part of this range. And if you are getting 2 squared minus 4, if you're talking about that 0, so that 0 is perfectly okay. We have solved quadratic equations using the quadratic formulas, and we used to get the discriminant equals to 0. So that was just a good case. Like we used to conclude the answers from there as well. So there's no problem with 0. Yes, x equals 0 would give you a problem, and that is part of this range. It is in this range. This does not have minus 2 and 2 only. Minus 2 and 2 have no problem. That is okay. The values between minus 2 and 2 are problematic, and this representation is basically this range greater than minus 2 and less than 2. They're not talking about minus 2 and 2, okay? Is that okay now? Okay, all right, very good, perfect. So let's talk about the third one now. So it says limit e to the power 1 by x and x is going to 0. So what exactly would it be? It is e to the power 0. So this is e to the power 1 by 0, and that is going to give us what? E to the power infinity. Yes. So
One.
what? Sorry?
Oh, that's 1 divided by 0. Okay, okay.
Yeah.
Sorry.
You're saying A?
Hmm.
Okay. All right. Let's think about it for a moment. So let's say we have a number 5.555. Okay. So we have 4 decimal places. And let's just cube this number. Okay. All right. And then, all right. Okay. Perfect. So this is basically going to give you infinity. And this was the example which we were talking about earlier as well. Okay, I thought that I did not explain this, but yes, I discussed this when I was on my whiteboard as well. So basically, if you have any number power infinity, that would give you infinity. All right, that is good, and there's no problem with infinity. Okay, in the indeterminate forms, we did not have infinity. We were having infinity minus infinity, infinity by infinity. So those were the problematic group, and infinity multiplied by infinity was also problematic one. Although one might say that it would be still infinity, but we don't accept that, so that would also be indeterminate. Okay. The fourth question is very interesting, and it would um, be something with if we'll talk about it, so we'll be referring to yesterday's class as well. It says the domain of the inverse of the function this is what? Now, this is a function, and we're talking about the inverse of this function, and we're specifically talking about the domain. So think about it for a minute and then tell me the answer.
Yeah, so basically you just have to convert, first of all, change the x will become the y and the y will become the x. And then rearrange, make y the subject of the formula, and then replace y by f of x, and then we should get our answer.
Okay, yes, that method is certainly correct. That is not wrong, it is correct. But in NET, you would not be having this much time. So there is a direct approach for this question as well, okay? We discussed such questions yesterday as well, where we had a function and its inverse, and I told you the domain and range would be used. So this is f of x, and we are talking about f inverse of x. Specifically, its domain. I do not have f inverse of x, but I do have f of x. What if I find the range of f of x? Because the range of f of x would basically be the domain of its inverse function. So I can certainly
Okay.
find the range, okay? I can see that what would be the minimal value, what would be the maximal value, minimum and maximum, right? Minimum and maximum. So that is going to give you the correct answer. So this is the function f of x equals 2 plus under the root x minus 1, okay? Let's say x is 1. So when x would be 1, this is going to give me 2, right? So the minimum value would basically come when this function would become 0, because this is my x. This is my under root x minus 1. And the minimum value would be when this under root x minus 1 is 0. So minimum value of the function could be 2. And we are using a square bracket because this 2 would be included, okay? And then if we talk about the maximum value, so we keep on increasing x, let's say 20, 25, 26, 27, 10,000, then 10 million, 10 trillion, stuff like that. So that would give us even bigger values, right? So it can go up to infinity. And whenever we're writing down infinity, we can never ever use the square bracket because we are not sure about what exact value is. So we always write it down with a circle bracket, right? So this is how we talk about such questions. Emma, the method was correct. You can do it that way as well, but this would be better from any point of view. This would save time, okay? So if you have a function and if you are looking for the domain of its inverse, you can think about the range of the function, and the range of this function will basically be the domain of its inverse function. The function was 2 plus under the root x minus 1. The minimum value can be 2. The maximum value could be infinity. And yeah, for 2, we are writing down square bracket because it can be 2 as well. So that is why if we had, let's say, 2.001 or 2.1, stuff like that, in that case, we would have used this soft bracket or this circle bracket, right? But since we know 2 would be included in this, so this is how we do it. Another way of interpreting this could be this is 0, this is 2, this is a solid circle, and it's going on continuously till infinity. So you can also think about it this way, okay? And if I talk about the answer, so that would be the same, but with a hollow circle and this way, because 2 would not be included, okay? Yes, Alina, is that okay? All right. Okay. Perfect. Let's talk about the fifth one. Okay. Yes, we did
Can
discuss.
you go up?
Sorry. Yes, sure.
Okay. For domain,
Hmm.
we put x is equal to 0, right? You put x is equal to 0. That would be minus 1 in the square root.
This whole function under root x minus 1 would be 0 when x would be 1. This is what I was telling you. Okay.
So I repeat it again.
This whole function under the root x minus 1, this thing would be 0. Okay. This would, when this would be 0, this would give you the minimum value of the function. It's not x.
Okay.
Wait a second. I'm sorry. I think this it is. Yeah, it looks like that, but it is basically this. Like it's basically the whole under root x minus 1 going to 0. Okay.
All right. 1 minus 1.
Yes. Exactly. X for x1. Yes, you're right.
Right. That's mean yeah.
Okay.
It was like that was okay. Okay. And these bracket values mean something anything. Like I could never have imagined.
No, basically
So
yes.
there,
Yes. So I'll tell you. Okay.
yeah.
If you
Okay.
have a and b, this means This is x, and a and b, both of them are included. Okay. If you have, let's say, this, it means this would be the range. Let's say you have this would be the range. Okay. This is how it exactly is. If we have square brackets, so this number and this value is included, other than all the values coming between a and b. If you have these brackets, you would have all the values between a and b. If you have one square and one soft bracket, you would have this a included, because the square bracket is basically being used just to tell you that this number right here would be part of the range as well, would be part of the interval as well. Okay. And then we would have all the numbers between a and b, and a would also be included. So this is how
So
it
D
is.
is the answer, right?
So B is the answer. B is the answer, because when this
Right,
thing
2
would
is
become,
included.
yes, 2 is included. Very good.
Okay.
All right. Okay. Let's talk about the fifth question now. This is x. Now, when we will plug in e, this is the same question we discussed earlier as well. This would give us e to the power p minus e to the power p divided by e minus e, and this is giving us 0 by 0. Now, this is certainly indeterminate form. In order to understand this, we need to use the L'Hopital's rule first and then talk about the solution. So this would become, now if I differentiate the numerator, it is x to the power p, it would become p x to the power p minus 1, and the denominator would become 1, and again the limit is x going to e. We will plug in e, and this would give you p e to the power p minus 1. So the answer is going to be D. So once you know it is indeterminate, we will be using the L'Hopital's rule. For L'Hopital's rule, you need to differentiate numerator, denominator. The derivative of numerator would be this, because we need to differentiate it with respect to x, and the derivative of the denominator would be 1. So in short, we are left with this function, and now we're going to plug in the limit, that is e. So this is the limit, and this is what we are getting, and the answer is D. Yes, is that okay?
Yes.
All right, okay, very good. Now you guys can try question 6. I'll wait for a minute, and if you are not able to do it, then I'll do it. Please try question number 6.
Question number 6?
Yeah,
Okay.
question number 6.
4 into 3, 12. 4 divided by minus 4. 4 divided by minus 4, minus 1. No option.
Please do it again.
Oh, 3. Sorry. 3 plus 2. It's 4 by 5.
Yes, very good. Okay, so obviously it's not necessary that we are getting indeterminate form every time. It could be that the answer is directly correct one. Okay. Yes, Alina,
Yeah, I
I
was
need
putting minus 6.
yeah. Okay, Alina, is that okay? All right, okay. Let's talk about the 7th question now. This is very simple. It says, given f of x equals x squared plus 3, then f of a plus b is. Now, instead of x, we are using a plus b. So you will plug in a plus b instead of x, and this would become a plus b squared plus 3. So it would be a squared plus b squared plus 2ab plus 3, and the answer is going to be it's A.
Okay.
Okay. All right.
Okay.
Alina, are you there? Any doubts with this? Okay, I got your message late. No, okay, all right. Okay, let's talk about the eighth question now. Please try doing it initially, and then if you guys are not able to do it, then I
C.
can do it. Very well done. Excellent. Okay, excellent. It would be C because it's very obvious. When we'll plug in 0, it would become 0, 0, 0, and 0. So it would be 9 by 17. All right. Okay. Okay, now this is since we were talking about functions, I did not talk about composite
Composite
functions.
function.
Yes, very
Yeah.
good. So just plug in g of x in the x
Exactly.
of f of x and then just tell me the answer.
I'm lying down right now. I'll do this mentally. Put 3. Okay. So 12x plus 15. 22. 12x plus, it's either A or B.
Yes, because you would be getting 12x.
Hmm.
Okay, Alina, can you try doing it? B. Very well done. Very good, Alina. This is going to be B and you guys know how to do it, right? So
All right.
you'll plug in the limits and then you would get 33 basically. All right, so this would be the answer. Okay, let's talk about the 11th question. So it says it's in front of you. We'll be plugging in x equals 0 and we do see that all of them would become 0 except this 8 and 5. So all this would become 0 and all this would become 0. So we would be left with 8 and 5 and the answer is going to be B, 8 by 5. Okay. Let's try using trigonometric functions for these now. So now we have limit z going to 0. It says sine p of z, so it would become 0 divided by mz and this is 0. Now we know that sine at 0 degrees is
Infinity.
0. No, sine at 0 is 0, right? So
Oh,
we have 0 by
right.
0. This is the graph of sine. At 0, it is 0.
So we'll have to differentiate.
Yes. With respect to z. Be very careful with this, okay? We need to differentiate with respect to
Okay.
this variable because we have multiple variables. So at times students are confused that with respect to which variable exactly we are differentiating. So please try doing this. I'll wait and then you can tell me the answers.
So differentiation of sine is cos, right?
Yes.
So cos of 0 is basically 90 and 90 by m. And that is 0. So 90 by 0 is infinity b.
Okay. And can you try doing it, Alina? All right. Alina, please try doing it. I'll wait. The answer is not B, by the way. So you can check that
Yeah,
again.
that's what I was thinking, right? So there's only m left. And so m should be in the denominator. So it's either C or D. What is a cos 90? Cos 90 is 1. Sorry,
So
cos
why?
0, my bad.
Yeah, cos 0. Cos 0 is 1.
Cos 0. Cos 0 is 1. Okay, then C.
C, right?
Right.
Okay, let's do it together. We know that this would give us indeterminate form, so we'll differentiate this. So when we differentiate sine pz, this would give us cos pz, and the derivative of this would be p. So we need to write that down as well. and we will be dividing it by the denominator. We'll take the derivative first. So derivative of mz would be m. Now we will plug in 0. So p into cos 0 by m. Cos 0 would be 1. So the answer would be p by m, and that is D. Yes, Alina and Emma, is that okay?
One second. That P behind the cos?
Because when you are differentiating a trigonometric function, you need to differentiate the
The
angle as well. Okay?
angle, right?
Yes.
The angle,
The angle,
yes,
yes.
yes.
Okay, perfect. Okay. Right. Now, this is another question. So it says, which one is true? The first one says e to the power x is going to infinity. The second one is saying e to the power x with x going to infinity is 0. And then the third one says a to the power x with x going to infinity is a. Think about it and then tell me the answer.
One only.
Very good. Excellent. Okay. This would be the answer. This is not true. This is obvious. And this is also not true because if you have a number a, you're putting infinity, that would not give you a. Okay. It depends obviously on the number, but yes, generally it would not be true. So that is why it has one only. All right. The 15th example is interesting. Let's talk about it. And it's easy as well. It says let A is this, B is this, and then R is a set. Then the domain of R is. Okay. We are looking for the domain of R and we have these points of R. Okay. So it's 3, 0, 5, 1, 7, -3, -9, and 0. The value of function at 3 is 0, at 5 is 1, and stuff like that. So think about the domain of R.
Domain are all the x values, right?
Very good. Yes.
So, see?
Very good. Well done. Excellent. That would be C. Okay. All right. Let's talk about this. Sorry. This actually. Yes. Now it says 1 minus cos 2x by x squared. So first we need to plug in 0. This would give you 1 minus cos 2x. X is 0. This would become 0. Divided by 0 squared. That would be 0. This is 1. So this is giving you 0 by 0. So this is certainly indeterminate. We cannot do it directly. So we need to use the Lopeters rule. You need to differentiate the numerator and the denominator and then plug in the limit. So please do that. And Narina, please try doing it and type the answer in the chat box.
Okay, let me do it as well. So that will become sine. So that would become sine. Okay, sorry, 2 sine 2x by 2x.
Okay, very good.
Put 0 and we'll get the answer.
And what are you getting after plugging in 0?
Okay. Let me do it mentally. 2 sine into 0 is basically 0.
Yes.
So the whole bracket becomes 0. 0 divided by any number is 0.
No, but that any number should not be 0, right? Because then that would give you indeterminate form again. So basically, once you will differentiate the numerator, that would give you plus 2 sine 2x.
Yes. Then differentiate it again.
Yes, very good. You need to differentiate this again.
So this time it will become cos. Okay. 4 cos 2x by x.
By 2. Okay.
By 2, sorry.
Yes.
Yes.
And now you'll plug in 0. So this would
So
become 1.
yeah, 2 is the answer.
Very good. Okay. This would be the answer. Yes, Alina, is that okay? No? Like you did not understand this question? Okay, I'll tell you. So basically, the 16th question is just like the other question, the other questions. The only problem was that after differentiating it for the first time, you were still getting the indeterminate form. Okay. So this is something I told you earlier as well. We will keep on differentiating this until and unless we get something that is not undefined, something that is not in the indeterminate form. Okay. So that is why once we got 2 sine 2x by 2x, we differentiated the numerator again and the denominator again and then plugged in the limit. So that gave us 2. Is that okay now? All right, perfect. Let's talk about the third one. For the third one, again, it's very obvious. 3 cubed is 27 and 3 squared is 9. It would give you 0 by 0. So you will again differentiate it and this would give you 3x squared by 2x. Now you will plug in 3 and this is going to give you 3 into 3 squared, that is 9, divided by 2 into 3. 3 and 3 would be cancelled and the answer is going to be 9 by 2, that is D. So this is going to be your choice. All right, okay. Let's talk about the 18th question. That is more interesting. Okay. It says limit theta going to 0 and the function is 1 minus cos p theta divided by 1 minus cos q theta. Let's plug in 0. This would give you 1 minus. If you have 0 here, this would become 1. This would also become 1. So 1 by 1, 1 minus 1 by 1 minus 1 is again 0 by 0. So you cannot talk about it directly. This is indeterminate form. So we need to differentiate both the numerator and the denominator again. Right. So let's try doing that. For cos, it would be minus sign. So minus into minus sine p theta, and we multiply the derivative of the angle, that would be p, divided by minus sine q theta into q. Okay, now when we will plug in 0, this would again not serve the purpose. This would again give us the wrong answer because sine 0 is 0, sine 0 is 0, so 0 by 0 again indeterminate. We need to differentiate it once again. So minus into minus would become plus. And yeah, let's differentiate it again. So p, let me write it down neatly just so we can understand the second differentiation again. Okay. So this was giving us 0 by 0. Limit theta approaching to 0 was giving us 0 by 0. So this is what we had. And now we need to differentiate it again. So p cos p theta. Now I'll multiply the derivative again, divided by q as it is. sine q theta into q. Sorry, this would be cos. The differentiation of sine is cos, obviously, and this would give me p squared cos p theta divided by q squared and cos q theta. Once I plug in 0 for theta, this would become 1, this would also become 1, and the answer is going to be p squared by q squared. So it would be A. Yes. Is that okay, Ahmed and Alina? Any doubts with this?
No.
All right. Let's talk about the next one. Okay, now this is also an interesting question. Okay. Now, for the 19th question, let's understand the question first. It says f of x minus f of a divided by x minus a, and x is going to a. Like x is basically a, the limit is x approaching to a, and the function is in front of you. It is basically f of x minus f of a divided by x minus a. Okay. Now let's just plug in the limit a and let's see what exactly we are getting. We will get f of a minus f of a divided by a minus a. Okay. And this is 0 by 0, and we do not have anything of this type, and we do realize that if we start differentiating it, we don't even know what exactly the functions are, so this would not serve the purpose. So
E
for, sorry,
should be D. E.
B or D?
E. Yeah, D.
No, look, D. Why D?
Okay. Because I just remembered that if there was no solution to such,
No,
we would
no.
just take
Yes,
an
yes, yes.
expression.
No, no. You are right. No, Emmett. Basically,
No?
you need to
Mm.
you need to have a question of that type, which we will come across
Okay,
shortly.
okay.
But this is not a question of that type. Okay. So you need to think about a similar answer. So you should get 0 in the denominator. So it looks like A or B. Okay. So C and D are obviously not the answers. If you look at A and B, this is h going to 0, and if you look at the expressions, this is h. So this would give you a 0 here, and this would give you a 0 here. Let's check out the numerators.
Mm.
This should give you f of a, this would give you f of a, and then we should have minus f of a. Okay, so the answer is going to
Yeah.
be B. I'll repeat this. For the 19th question, it is a bit different, and once you'll study cal 1, cal 2, cal 3 in university, you will understand that this is basically how we discovered differentiation. Okay, but at your level, all I want you to understand is that the example in the question is just like another example in the B part, another function in the B part. Once you'll plug in the limit, you would again get a similar type of thing. So this would give you f of a minus f of a divided by 0. Okay, so this was also giving f of a minus f of a divided by approximately 0. So that is why the answer is B. Yes. Any doubts with this, Ahmed and Alina?
No.
All right. Okay. Perfect. Okay. Then the 20th question says the inverse function of y equals x by x plus 5. Now that's very simple.
Now that
Now,
method, right?
yeah, that method exactly.
Yeah.
So you can just differentiate it and then tell me the answer.
Differentiate it?
You can just find the inverse and tell me the answer.
Okay. So x is equal to y by y plus 5. Okay, it will go there. Unfortunately, I have to get up for this now.
Mm-hmm. Yes, it's okay.
Or I could use that annotate feature.
You would not
That
be able to do
can.
that in the exam, okay? So please try doing it on your own.
Is this okay?
That is okay. if you get enough space.
Y plus 5. And now I'll just rearrange this. This whole denominator will go to the other side and x will come down. Actually, there is no need of doing that. I could just make it go there and picking up the pen.
Yes, Alina, you can tell me the answer if you were able to do it.
Okay. Take -1 common. So is it 5x? Is the answer D?
Yes, the answer is D. Very good.
Okay.
Okay. Yes, wait a second. Yeah, can you disrupt this because I am not able to.
Okay. No, I almost saved it. 1 second. Cancel. Where's the razor? Yep.
Okay, thank you. All right, now, Alina, are you there? Please pay attention. Let's talk about, we just have 3 more questions and they're very important. So let's focus on these, okay? It says, limit cosecant pi plus h, and h is basically going to 0. So cosecant is 1 by sine. So it would be 1 by sine pi plus h, and h is 0. So this would basically be 1 by sine pi. Sine pi is 0. So 1 by 0 is what? It would be 1 by 0, and that would be infinity. So the answer is D.
Okay.
Very good. And for this 22nd question, it says the graph of the function y equals log x has an asymptote at. Now, Ahmed, are you familiar with asymptotes?
Yes.
Okay, perfect. Then can you think about it? Do you know how to make the graph of log x? Log of x?
Log of x is okay. I've done exponential graphs and logarithmic graphs, right?
Yes.
So log of x is it exponential or logarithm?
It is logarithmic.
Logarithm, right?
Yes.
So Lin's graph, right?
Yes.
Okay, so Lin's graph is basically like this. Where's my pen? It's basically like this, right?
Yes, very good.
The
Very good.
normal line x.
Yes, that is correct. So the asymptote would be which line?
So the asymptote would be the y-axis.
The y-axis,
You
exactly.
know,
And how do we write
yeah.
down the y-axis? With x equals 0. Okay?
With x, yeah, with x is equal to 0.
0. Very good. This would be the answer.
But why would it be x is equal to 0? Okay, yeah, exactly, right.
Okay.
That and yes, okay.
And Alina, are you okay with this question? No, okay. So Alina, basically, I'll make the graph quickly. So for this, we should know some basic plotting. Why is it going like that? Okay. This is the y-axis and then this is the x-axis. I'll make the graph of log of x. So it is something of this type. Okay. Now you can use your calculator and check what is the value of log when x is 0. So just do log 0. Yes, Selena, I'm waiting for your response. I just want you to just check one thing. You would get error, okay? You would get error, okay? And what do you get at log 1? At log 1, you would get 0. This is x, and this is basically log of x. So the value of log when x is 1 is 0, okay? And this is the origin. This is the line where x is 0. If you plug in log 0, you would get an error. That means the value is not defined. So that is why our graph goes on like this continuously, okay? Since the graph is getting parallel to this y-axis, so we call this the asymptote. Okay, now you must be familiar with a few graphs of this type. Let's say if I talk about this, so here we have two asymptotes basically, y-axis and x-axis, both of them are the asymptotes. Okay, then we have if I talk about the exponential graph, that would be a good example. So it would be something of this type. Okay, so here the asymptote is this x-axis because the graph would get parallel to the x-axis. So if your graph is getting parallel to any line or any axis, that line or axis is basically the asymptote. And that is why for log of x, we are choosing x equals 0 because x equals 0 is basically the line of y-axis. Is that okay now? Okay, perfect. And then this is the example where you need to use that. Okay, let's do this now. It says limit x is approaching to infinity and it is x by 1 plus x to the power x. Okay, so we are going to get infinity over infinity to the power infinity, and this is certainly not an acceptable form, so we need to do something about it. Okay, now if you start thinking about factorizing, or if you start thinking about taking the derivative, the differentiation of numerator and denominator is not that straightforward in this case, because this time around you would have
Yeah,
something of
because
this type, x to the power x.
ln
Yes,
would be involved, right?
sorry, say it again.
In the differentiation, the ln, because it's linear function. But
Yes,
we
but
won't,
but
because
but, but look, yes, it apparently it is a, like, this is very easy. This is very easy. We know how to differentiate these, but you know you have this x as well, so it is exponential as well. So the
right.
differentiation of such cases is very complicated, and that is why we talked about that one theorem. All right. So
E.
what exactly was the formula? Yeah, we discussed two. We discussed A and B. So what do you think? Which one would be used for this one?
We also use p as power of e, right? So that's over
Yeah,
here.
exactly. That one. That one. I'll tell you. Wait. Let me
Okay.
write down the theorem first. It was limit x approaching to infinity, and it was 1 plus p by x to the power x equals e to the power p.
P.
And then I told you
So,
instead of p, we can take any number. So let's talk about 1. Now, this is the function which we had in our
right.
theorems, and this is what we have here. So there is a minor, like you can say a major as well, but there is a difference in both the functions. And we need to make sure that we do that thing with this as well to choose the answer. Let's simplify this theorem, this thing. So this would give you, if I take the LCM, it would give you x and then x plus 1. This is what it is, and you can just clearly see the question which we have. Okay, so it is basically the reciprocal. Everything is same. The only difference is
Right,
that we
that's
have the
E
reciprocal.
minus 1. That's
Yes, very good. Okay, so if the answer was E in this case, for our case, it would be e to the power minus 1. I'll repeat this one last example for Alina. And if you have no doubts, Emma, then you can leave the meeting because we are done with this. Okay. So Alina, basically for this question, we need to use that theorem because we cannot differentiate the numerator and the denominator directly. Okay. Now I'll erase this and this is what we have. Okay. This was the theorem A that we had. And if you look at it, if you simplify this function, this is what we are going to get. Okay. And this is not same as what we have. We have x over 1 plus x, and this is x plus 1 by x. So this is basically the reciprocal of the function which we have. The answer was E for this in the theorem. Okay. So if I take the reciprocal of this would give me the function that I have. And so if I will take the reciprocal of E, this would give me e to the power minus 1. That is why the answer is D. Yes, is that okay now, Alina? Okay, all right, perfect. So I'll stop sharing this. I'll stop the recording.